released. Welcome to our third webinar. Our topic for today is going to be the state of the art in data warehousing. My name is Milan, and I'm the CTO of Infostrux. We are a data analytics services company focusing on data engineering on Snowflake platform. The webinar today will be presented by our VP of Technology, Mr. Pierre Cliche. Please do post your questions on Zoom as they come up. We'll have a Q&A session at the end of the presentation. Pierre, take it away.
Awesome. Thanks, Milan. All right, so let's get the show on the road. Today, I'm going to be talking about data warehousing. One thing I would say right away is that this is not meant to be a super deep, highly technical, in-depth view at everything you can do today in data warehousing. This is meant as a little bit of a recap on the industry and kind of where it's going in the future. This is very business level. Just to manage expectations here, still, I think there's a lot of value in it. So let's go right into it. The first thing I want to do is I want to bring up a question. Data. Why do we care about data? If you ask about anybody, right, they will tell you, oh, data is valuable. Data is valuable. That's what you're going to hear times and times again. But the truth is, that's not exactly true. Data in and of itself doesn't mean isn't value. It's unrealized, right? Data in a vacuum is essentially worthless. You don't get much out of a single data point. What really drives value when it comes to data is a combination of two other things, structure and context. The real anatomy of value that can be derived from data looks a little bit more like this, whereas a lot of people just see data and think that this is a means to an end, right? The real value of data is really made up of three things. Data, of course, which is foundational. Context, and in this case, context would be the output of data analytics, right? So everything you do through reporting, dashboarding, predictive analytics, right? Everything that goes through those tools like Tableau or SageMaker. Let's say that you do, you're big into machine learning analytics. The idea being that the actual output of value goes through data analytics, and it's highly visible as an extension. But what we often seem to neglect is structure, data engineering. So everything that has to do with centralizing data, making it easily available to the analytics tools, right? Cleaning it, integrating it, modeling it, documenting it. All of this is extremely important in actually generating value. So this begs a question, right? So for most organizations out there, it seems to be pretty difficult. Like the recipe seems simple. So why is it that so many businesses are struggling to actually realize value out of the data they collect? And the answer is pretty simple. If you look out there, a lot of organizations actually look something like this, right? This is how they try to realize value out of data. They overinvest in the context part of it, in the analytics, and they underinvest in the engineering part of this. It's kind of easy to understand why, because when it comes to data analytics, it's kind of the obvious target, right? As a business leader, if I don't have deep expertise in data, like if I don't understand the field very well, I'm going to make a very simplistic decision at the onset of my entire data strategy. I'm going to say, you know what? I want to do BI analysis, right? I want to do machine learning. So of course, I'm going to turn around and say, hey, I'm going to hire BI analysts and data scientists. It's in the name. It's just logical to go this way, right? And the other thing is, it's very visible. By virtue of being the piece of your data strategy that's actually client-facing and user-facing, everybody sees data as analytics. So this leads to a situation where very often you will see organizations underinvesting in their data engineering group and the structure of the data. So this leads to several very important problems. The first one being the high confidence, low quality pitfall. This is a situation where you've invested so much time and effort and money in your analytics platform. You're going to trust it, right? You're going to be confident. I mean, it's state of the art. But because you've underinvested in the data engineering that supports it, you end up with an analytics platform that gives you wrong answers. This is how you end up in a meeting with your CEO with 3 people reporting on the same thing, with the actual reports showing different numbers, right? That's low quality data. That's poor harmonization. And this brings us to the other problem, which is that by poorly integrating your data, you end up with data silos and fragmentation, which means that every single business leader in your organization is going to make decisions that are not based on how their own KPIs interact with others in the business, right? So they will make very short-sighted, self-centric decisions that may actually hurt the business more than it helps it. And the other big thing is that you are deeply weakening your analytics velocity. What I mean by that is that by over investing in BI analysts and data scientists, what you end up doing is putting the burden of data engineering on their shoulders, as opposed to the data engineering group, right? So you end up with highly specialized resources that don't do what they are supposed to be doing, which is generating value through analytics, for about 70-80% of their time that they spend just tinkering in ETL pipeline and just messing around with data. So just wrangling data doesn't generate value, right? You want them to focus on what they're good at. So this is why it's so important to put emphasis on data engineering, on data warehousing as well. Because at the end of the day, analytics can do more harm than good without proper engineering. And this brings us to the data warehousing, right? Like the crux of this presentation. When it comes to data warehousing, it's important to understand where it's coming from, right? Data warehousing first came into existence out of the need to have a single point of truth. In organizations where you would have, tens of systems or hundreds of systems interacting with each other, you needed to be able to get actionable information, actionable insight out of a single database. You couldn't just always be running around trying to fetch data from left and right. And this is what fundamentally a data warehouse is all about. So the first iteration, the first crystallization of the data warehousing architecture looked a little bit like this, where the objective was very simply to centralize data and make it available to analytics tools. We would have structured data sources, meaning SQL databases, CSV files, that would be ingested into your data warehouse through a staging area, for example, using something like an ETL pipeline. One thing I would note here is that I'm not going to go too deep into the ETL side of things today. Just keep in mind that whenever you see arrows going from one stage to another here in the data warehouse, this is generally an ETL pipeline or an ELT pipeline that's actually taking the data and moving it around. But yeah, so the idea in this traditional data warehouse is that you're incrementally loading whatever has changed since the last load in your databases. You are normalizing it, cleaning it inside of your enterprise data warehouse. And by the way, this wasn't always happening, right? Like sometimes you would have organizations bypassing this step out right away and just going to the data marts, which I'll cover a little bit. But at the end of the day, this is what you would see the most of. And finally, yeah, you end up with the data marts where you actually do dimensional modeling. So the idea behind dimensional modeling and the difference between normalized tables and dimensional modeling is that you actually want to make the data as easy to access and as palatable as possible to your analytics tools. You see here that you have several data marts for any one data warehouse. The idea being that a data mart is essentially a subset of your data warehouse that is specialized to one single business unit or one specific use case that you want answers about. So if we go back to what a normalized table looks like as opposed to a dimensional model, the idea here is basically that you want to make the data as readily accessible as possible, right? So instead of having to jump across tables to get any sort of useful information, you want to flatten everything into a model that is useful for your analytics. So that's what it boils down to. The reason why I address this is because there's a lot of talk about dimensional modeling or data modeling as a whole. And oftentimes I realize speaking with business leaders that they don't necessarily have a good grasp on what it means to differentiate between the two. So this is really what I wanted to give you here. So what we're left with traditional data warehousing is a situation in which to generate value, every single piece of data that you're going to be using has to be structured at the origin, right? It has to come from a structured data source. You have to, again, for every single piece of data, you have to analyze it, understand it, extract it into your staging environment through an ETL pipeline and an ETL job. You have to clean it, you have to normalize it, you have to load it into your enterprise data warehouse, and then you have to further model it and make it available through your data marts. This is for every single piece of data that you want to potentially use as part of your analysis. It's very inflexible when it comes to trying things. Like if you have a new data point that you wonder, hey, could I actually make something good out of this? Well, you have to go through this entire pipeline to make anything out of it. Which means that in the grand scheme of things, if you look at kind of a breakdown of the effort that comes with the different tasks associated with building a data warehouse, you end up with a very high upfront investment in your data pipeline design and development, because you have to build all of those ETL jobs for every single data point, right? You have no real leeway there. And the one advantage of this approach is that if you look at the expertise that's required to do something like this, it's extremely narrow, meaning that generally this would all happen within the same platform with, of course, an ETL pipeline thrown in the mix. And by extension, the expertise required to get good at this would be relatively limited. I mean, limited in terms of breadth. I want to make that very clear. I mean, you would have deep expertise, but you know what I mean. So this worked well until big data became a thing, right? With the advent of, bigger internet throughput and everything becoming connected nowadays, big data has become a very real part of our reality, right? And as you may or may not know, big data is defined by three main elements: variety, velocity, and volume, the three V's of big data. And if we look at how this stacks up against traditional data warehouses, what we see right away is that in terms of variety, well, right there, one strike, traditional data warehousing would mainly work with, only work with structured data. In terms of velocity, you could do it with a traditional data warehouse. Like you could handle a high velocity, but it would be clunky at best. And in terms of volume, again, you can absolutely do volume with a traditional data warehouse, but it leads to massive operational overhead, right? Like you end up having to manage your partition, you have to manage the underlying hardware at an increasing fraction of your time, and the value you extract from your data warehouse at that point becomes, well, it diminishes greatly. So to respond to that, the industry has moved towards a new model, a model we call the modern data warehouse. And when we say modern data warehouse here, we don't mean modern as the actual point in time. This is just how this model is called. When we look at the modern data warehouse architecture, what we see right away is that there's a much greater variety in the data sources it can actually support. And the reason is simple, right? This was imagined, this was built from the ground up to handle big data in the context of the data warehouse. So this is where you start seeing data lakes, right? The implementation of a highly scalable object store to be able to handle all of those varied types of data without having to invest right away into transforming everything into structured data that you can then send through your typical data warehouse. One of the big advantages here is that you're introducing a highly scalable compute layer, right? So the compute layer here allows you a lot of flexibility in terms of what you do with the data you collect, because now you're not limited to transforming everything in a single harmonized way right away with your ETL pipeline going all the way through. Now you can actually try things, and you can potentially even run much higher scale compute on your data, which is very interesting. You also end up with the ability to run ad hoc experimentation. So, I put a lot of emphasis on the fact that traditional data warehouses would be limited in the sense that you would have to transform every single bit of data you would want to do anything with. Well, this is not the case anymore. Now you have all of the data available in your data lake. You can run transformations, you can experiment on it before you decide that the data actually has value and that it should be sent through your pipeline and made available through your typical data warehouse. One thing I will note here is that your traditional data warehouse still exists in a certain form as part of this architecture, because at the end of the day, it's one of the most efficient ways to actually expose data to your analytics tooling. But the difference here is that a lot of the transformation and a lot of the more exotic data sources are handled differently. And ultimately, this enables a lot more use cases, right? And this is the entire point of modern data warehousing. You can do a lot more, and you don't have to invest as heavily ahead of time before you can try anything. It does come with a fairly massive trade-off, though, right? It's no longer a single platform, right? You have a bunch of systems interacting with each other that are of increasing complexity, which means that suddenly you don't just manage your data warehouse, your database. You end up managing tons and tons of different technologies with which each have their own way of doing things. So now you're no longer dealing with a platform, you're dealing with a complex system. The other thing is this requires strong governance. So because your data is actually moving between systems and is a little bit more all over the place, you need to invest much more heavily into actually making sure that you know where that data is and keeping track of everything that has to do with it. So if you look at the trade-off we get out of adopting something like modern data warehousing, what we really see is, sorry, I'm going to clear my throat. All right. So what we're seeing here is that we have greatly diminished the investment we have to make in terms of data modeling and data pipeline design and development. But the trade-off is consequent, right? The expertise that you need to operate your infrastructure is suddenly much wider. So it's much harder to hire for, it's much harder to account for, and it requires much more investment. And yeah, so to summarize all of this, you end up with greatly expanded capabilities at the cost of complexity. I'm reading the slide for you so you don't have to. So this brings us to today. One thing I will point out right away as a disclaimer is that even though we called this webinar a state of the art in data warehousing, the truth is state of the art will always vary a little bit. Like it's always going to be an evolving standard. So I don't mean to say that we have the absolute truth here, right? The other thing I want to address here is the fact that, well, we are a consulting firm specialized on the Snowflake data platform. Wow, I really have an issue with that cat in my throat. So yeah, we are specialized in Snowflake. So by extension, we are going to use Snowflake as an example here. But I really want to put emphasis on the fact that those trends that we're addressing here are actually industry-wide. So what we're seeing is that more and more data technologies are moving to the model of a managed cloud. Even the more traditional ETL technologies, Informatica Talent, are moving towards a model where the vendor is actually operating most of the nitty-gritty of the tool, and your team is freed up to focus on what actually generates value. It's this notion of avoiding undifferentiated heavy lifting. So if we look at data lakes or data warehouse alike, everything's moving to the cloud and it's becoming increasingly managed. Likewise for the ETL. The main driver here is to optimize capability in relation to complexity. So one thing we did by adopting the modern data warehouse architecture is that we have greatly increased capability without controlling complexity, which led to a very unfavorable ratio of capability to complexity. So now vendors and technology in general is gravitating towards a model where capability is very high, but complexity is getting as low as possible. And this is what we see with the data cloud model, which Snowflake has adopted. So in terms of the data cloud, we see that we have much the same capabilities as the modern data warehouse architecture. But everything is contained within a single platform, which is fully managed, meaning that a lot, and I mean a lot, of the burden of implementation and management is removed from your team. You can achieve a lot more with a lot less resources. And the other big deal here is that we are suddenly dealing with a harmonized compute layer, meaning that you can actually leverage your data warehouses or your data cloud, in this case, capability to handle all of your compute, as opposed to having to rely on an external system that will take the data in, transform it, and make it available to the next stage. This has a lot of benefits, right? So you don't compromise on, or you almost do not compromise on the modern data warehouse architecture. I will speak a little bit more to that after this. But you can focus all of your expertise into one bucket, which is SQL in this case, right? Nowadays, especially as complexity is increasing in the data field, what we're seeing is that traditionally very deep people in data have a hard time adapting to the new technology because they have to handle DevOps and infrastructure as code and a whole bunch of stuff to be able to get their job done. With a platform like this, they can keep focusing on what they know the best, which is SQL, and they can actually handle the underlying infrastructure and the underlying compute using this very same engine. It's fully managed, so you don't have to invest as much in your engineering team. You facilitate a lot of the quality of life things. So when you have a single platform like this, and this is especially true from Snowflake, the other platforms are kind of catching up in that regard. When it comes to dev and testing environments, well, since everything is managed at the same place and the data is centralized around the data lake, it's much easier to build dev and test pipelines where you can experiment freely without having to implement full duplicated instances of your entire data pipeline. Likewise, data management is much simplified because all data access, all data governance basically happens in the same environment. And more what we're seeing, and this has been adopted by not only Snowflake, but AWS, and I believe GCP has announced it recently, you can now do data sharing, meaning that amongst organizations that are actively using those data clouds, data, cleaned and useful data sets can actually be shared between organizations with a very low level of hassle and friction. This opens a lot of doors. And it's going to be very exciting, I think, in the upcoming years to see exactly where this data ecosystem actually takes the industry. There are some challenges to this. And the main challenge, honestly, comes in the form of flexibility. At the moment, since SQL is the main compute engine, you can do most of the things you could do with the Sparks of this world, for example, but not all. There are definitely things that aren't as available as part of this technology. Like as soon as you kind of lock yourself into a single harmonized technology to handle all of your compute, this is bound to happen. But the technology is evolving very quickly. And in the case of Snowflake, for example, they are soon to introduce a new functionality that allows for the execution of Spark-like jobs inside of Snowflake using their own compute. So I see that the time is flying. Luckily, I have reached almost the end of my presentation. One thing I would invite you to bear into consideration as you think about the data cloud model is that suddenly the investment you have to make in data modeling, design and development, and all of the infrastructure stuff becomes very low. You still have a very narrow field of expertise required to operate the entire thing, but you get all of the value that comes with the more complex architectures. And that's about it. At the end of the day, doing data engineering well is getting easier. The investment required to actually get value out of your data is becoming less and less, and that's a great thing. However, you still need to prioritize data engineering as you build your data strategy. And that's it for me.
Thank you very much, Pierre, for this excellent presentation. I think we do have time to answer a couple of questions that were posted. Perhaps what I'll do, I'll start with the first one in the list. Here is the question. I often hear that the data democratization is driving a lot of changes in the industry. What is your view on data democratization, and what role does the data warehousing play to empower more users to access and gain insights from the organizational data? Pierre, would you like to take this one, or should I try to attempt to answer this particular question?
I mean, by all means, go ahead, Milan.
Sure. So data democratization is really about making more users or giving more users access to the data, and therefore making it much more widely used, much more useful, and much more valuable. And I think data warehousing is actually responding to this particular to this particular need very nicely. It does the main purpose of the data warehousing, as Pierre was saying, is to put together a proper structure so that the data is easily accessed, and you don't actually need the expertise that the data engineers would bring in order to understand the data, the very details, and then format it or put it together into structures that can be easily and more importantly very reliably queried. So once the data warehouse is in place, suddenly pretty much everybody that has access to tools such as Power BI or Tableau or similar data analytics tools can become a data hero. They can come in and then use those tools on a variety of data sources which has already been combined, which has already been engineered properly, without needing to understand all those little pesky details of such as statuses and fancy dates, and then the actual business logic behind behind the applications that provide the data. Honestly, without data engineering of some sort, it is very difficult to let users access data directly. They may be able to query to query individual data sources if they are nicely structured, but quite often they're not. This is not the case, and the moment the moment the users would like to see the data from a variety of different places, the variety of different sources, the data warehousing is basically a must. So that will be, I guess, our answer to that particular question. I think the next one is related to typical recommendations on KPIs that the modern data warehouse architecture should measure. And the question is really, what are the KPIs? What are the things that the data warehouse builder should be looking at? And then there was a quick comment in the question, which is, I assume telling the CEO you'll get your data from yesterday in mid-June would be a bad idea. Definitely, that would not be that would not be a very good answer. So in terms of measuring the delivery of the data warehouse or the deliverables of the data warehouse, what we can do there is to measure perhaps three different aspects of it. One is related to qualitative measures. So these would be things like, or perhaps one of the most important ones would be compliance. Are we in compliance with the privacy policies? Are we coming in compliance with GDPR? Are we making sure that the privacy of our users is protected properly? So this is something that the properly delivered data warehousing project would address through data governance and through other tools. The other measures are quantitative. So this would be, I think, the measure that was mentioned by the questioner was one example of it, which is latency. How quickly can we actually move the data from the data sources to become available for analysis or to become available for reporting or to answer some questions. So latency definitely very important, and it does depend on the business. Some businesses need it right away, which leads us to real-time data warehousing, which is a little bit a different beast. Some businesses are okay with 1 day latency. Most of the businesses would like to see the data latency in minutes or so. Of course, the number of supported users, the number of users that are actually using the data warehouse would be a very important measure of the success of such a project, as well as the number of sources, number of dimensions, number of facts that are being integrated would not be necessarily a bad things to mention. But perhaps the most important thing to measure on data warehouse is the ability to enable new use cases or new business new business channels, and that's really measuring the ROI of the whole investment. So one of the typical examples would be to enable measuring or preventing customer churn, where the data warehouse is the place that actually integrates the data from multiple or variety of different sources. That each of the sources holds a little bit of information about the customer. It puts it all together, and then suddenly, because the information, all the information that the business collects from about their customers is suddenly available, um, it is possible to predict whether the customer has high probability of churning or leaving the platform, or perhaps or perhaps buying next thing. So really, the ROI the ROI question is perhaps the most important one, and the reason is that data warehousing enabling new lines of business, or enabling new business use cases. Um, uh, these well the sorry the ROI related to enabling new business use cases is by far more important, by far larger than ROI that you see by just being able to analyze the information. So really, at the end of the day, it is about picking the right use cases that will drive the data warehousing, and right questions that need to be answered, that drive data warehousing, that help the business. Um, Pierre, I have a question here on the data sharing. Perhaps you can talk a little bit more about that. Perhaps I'm curious, or the question here is curious about the future of data sharing. How do you see it? Do you think the Snowflake will finally solve this holy grail of business intelligence?
Wow, solving the problem, I don't know if it will definitely solve it, right? At the end of the day, I think that a lot of the major data platforms are moving towards a data sharing model. And if you guys on the call aren't familiar with the concept, there's this notion called data gravity, where the more data is aggregated in one place, the more data will tend to go towards that one place. And I fully expect that whichever player will be able to accumulate a critical mass in terms of data available through their data sharing platform will probably become at least some sort of a de facto standard. Um, I know that this is a little bit of an overstatement, because at the end of the day, it would mean that everybody would agree on a single standard for data warehousing, for example, which will never happen. Let's be honest. But I expect that it's not impossible that in the future there's going to be some sort of a standalone data exchange platform that may actually be either built as a result of cooperation between some of the bigger players, or just as an independent effort that will be compatible with most of those platforms, and will actually lead to much greater value realization across organizations. I know I can confidently say that the market is going in that direction. The actual shape it's going to take, I think, is still very much in the air.
Awesome. Thanks for the answer. There is a guest asking about differences between Redshift and Snowflake, and whether you can
Mhm.
perhaps compare them, mentioning some pros and cons
At,
of each.
at the, sorry, go ahead.
Yeah, just perhaps mentioning some pros and cons of each of the platforms.
Mhm, mhm. So at a very high level, what I would say is that using Redshift does come with certain drawbacks. So overall, it's even though it's maturing very quickly, for a good amount of time, Redshift was lagging behind in terms of sheer features. It will still require a fairly high operational overhead when compared to Snowflake, for example, where you would have to handle a lot of your integrity configuration on your own. The other thing that comes with that's inherent with any AWS product you may be using is the fact that not everything is harmonized in a single a single platform. So for example, let's say that you want to manage granular access to your Redshift database, then you're going to be using a series of systems, notably IAM, that is its own thing, right? That's not immediately available through Redshift. Whereas if you take something like Snowflake, you can handle all of your configuration straight inside of the tool, because everything is kind of part of the same system. So in terms of simplifying the configuration of the environment and managing the underlying infrastructure, Snowflake has the advantage there. Where I would say there's more of a disadvantage is probably in terms of sheer flexibility, right? Because by virtue of Redshift sitting at the center of the AWS ecosystem and being pretty well integrated with everything that gravitates around it, you potentially have more use cases that are accessible through Redshift. But at the end of the day, I think that those differences are relatively I'm tempted to say they're relatively minimal because as time goes on, I think there's a much bigger overlap in terms of compatibility between, let's say, Snowflake and other data platforms and their services. Um, so that's my general take on this. I would say that the biggest advantage of Snowflake is that it's a harmonized interaction layer versus Redshift, which is sitting at the center of a very rich ecosystem and can leverage that to its advantage.
Mm-hmm. Then I have another question along the same vein, which asks about Spark Databricks on Azure platform, and how would they compare, or generally the data services on Azure, how would they compare to something like Snowflake?
Mhm. Well, I would say that the answer is going to be relatively similar in terms of integrations and simplicity of use and all of that. Um, One thing I would say is that right now, where Spark is available on Azure, there's going to be an analog to that available in Snowflake relatively soon. So there's going to be less difference there. I think that at the end of the day, what's going to be, the most important is the fact that Snowflake is much simpler to handle in terms of operational overhead. I think I come from the cloud world, and that has always been my spearhead. Like the main thing I would always obsess on whenever I would work with customers, it would always be how do I make the operational overhead as small as possible, because that's when you generate the most value. That's when you get rid of undifferentiated heavy lifting. That's when you can actually make a difference in the organization. And I think that Snowflake is doing a very good job at that. And they're also facilitating the transition for data experts to go from those more traditional systems to the new way of doing things. So yeah, those are kind of the things I keep bringing emphasis on. That is to say, I think that the platforms that are platform specific for Azure, AWS, GCP, are still very solid products, right? Like at the end of the day, I think there's definitely a case to be made in certain instances that one technology might be better than another, but I don't know that this is going to hold for too long. Another thing we have to consider here is the fact that Snowflake has the advantage of being very multi-cloud friendly. So organizations that are going the multi-cloud route might actually benefit from using Snowflake as a franca of sort between their different platforms. It's kind of a neutral ground which doesn't require any specific integration at the ACL level for that or that cloud, right? Everything can be centralized in Snowflake and be fairly non-opinionated when it comes, as opposed to the different cloud platforms. So in a way, if vendor lock-in is what you're afraid of, I would say that Snowflake being, using NC SQL all across the board, being fairly easy to integrate with the different cloud platforms is probably your best bet in terms of mitigating that impact as much as possible.
Thanks. That's awesome. Pierre, I have a question about putting organizational data in one place. Would you do that? Would you recommend getting all the data into a single place, say creating an open data lake before you would start modeling and analyzing it, or would you take a different approach when starting an analysis project as a clean slate? I mean, basically, would you start with getting everything in, or would you go a little bit differently about it?
I think that may be overkill. This is actually one where Milan, you may have a very good insight as well. But my general take on this is that you don't have to get everything. Like your data strategy doesn't have to be built around extremes. What's most important, I think, is to identify the precious few use cases that are going to generate the most value for organization and build around that. Focus on that as opposed to focusing on getting everything done. Because as soon as you start trying to do everything all at once, you end up with the same in the same pitfall as data, traditional data warehousing would, which is to say that, oh, let's handle all of the data before we start generating anything out of it. So I would say focus on identifying the precious few data sources that will really make a difference, that you're going to be able to demonstrate business value to the rest of the organization with, and then start integrating the rest of the data. In a more general sense, yes, I think that having all of the data available in the same body of data is probably a good thing, because then it simplifies the modeling and analysis a great deal. But take it one step at a time. What's your take on this, Milan?
Exactly. It definitely needs to be use case driven, focusing on the data that's relevant for the particular use case, and then once we do that, once we pick the particular data sources that do make sense to integrate first. At that point, we can think about loading all the data from one particular data source if it happens to be easy to simply make it available to all the data science use cases or to all the deep data exploration use cases, or whether just to pick and choose. With Snowflake nowadays, it's very easy to load the data from one particular from one particular source, and then simply leave it there without doing much with it, simply because because storage is so cheap these days. And these actually the same patterns are followed on pretty much all the modern data lake architectures or modern data warehousing architectures, where the data can just be sitting there. But on the other hand, there is definitely no need to look at all the data sources before we start modeling one particular one, or to look at all the data sources before we can start generating very specific business value based on a very specific business use case. Yeah, I definitely agree there. Um, Perhaps one question, if you can talk, Pierre, just a little bit about data governance and how it
Mhm.
fits with data warehousing.
Right. So um, data, this is a very wide question that, and the answer to that will vary greatly from one type of organization to the next. But I think that typically data governance as part of those platforms, I mean, at the end of the day, it benefits greatly from moving to a centralized platform, right? Like if you have one key learning to take out of this, it's this, right? When it comes to managing your data, let's say that you're a financial organization or dealing with, highly sensitive PII, having all of the data in one place, manageable through the same ACL, this makes a world of difference. It also simplifies a lot the notion of auditing access and managing fine grain control. As soon as you add other systems to that, well, you introduce a ton more complexity and you introduce a lot more blind spots. So my general recommendation when it comes to data governance is keep it as simple as possible. Limit the number of systems where you have to establish your governance and manage access. I would argue this is probably one of the other weaknesses of the major cloud platforms offerings, which is that they typically don't have a single point of entry for their technologies. So this means that you have to handle access control and auditing at several layers, which sometimes makes for a much more difficult experience.
Thanks so much for that, Pierre. And I think that will be our last question. Time is flying very quickly. So I would like to thank all the participants for their time. Before we close the webinar, let me bring your attention to our next webinar, which is on the next slide. This is our guest is going to be Soma Segar. Um, Soma is a managing director at a well-known Madrona venture group, investing in a variety of technology areas, including machine learning, artificial intelligence, intelligent applications, and many others. In his previous life, Soma served as corporate vice president of the developer division at Microsoft, and he's also a former member of the Snowflake's board of directors. Soma will be chatting with our CEO, Kima, about Snowflake, data analytics, data applications, and many other topics. So please do register if you have time or if you are interested in this particular webinar. I believe the link will be posted on our LinkedIn as well as on our website. And I think that concludes our webinar. If you'd be so kind, please have a look at our survey at the end of the webinar. It will be very much appreciated. Thank you very much again for your time, and have a wonderful day.